So welcome to our first class on 228, and our first topic that we get into in this particular class is blood, which is actually, believe it or not, one of my favorites. So we are going to talk with this first video a little bit about general characteristics of blood. So you're going to learn some of the things about it, its consistency, those kinds of things in the body, and then we'll talk about its function, so what it does, why we have it, why it's necessary. And then the last thing that we'll do in this particular video is we'll get into talking a little bit about its composition, so what it's made up of, and you'll get to learn about those things. So going back to the characteristics of blood, we all know that it's red, right? But the exact color of blood actually depends on how much oxygen it's carrying. So if you look at this picture here, we've got these two vials of blood. This one on the side is a bright scarlet color, and the reason for that is this is arterial blood. It's coming out of the arteries and it's really highly oxygenated, and having that high oxygen color or content gives it that bright red scarlet color. If you look at this vial of blood, this is venous blood, so it's coming out of the veins. It's blood that's given up a lot of its oxygen, and the oxygen content is not nearly as high. So you'll see it's kind of a darker, almost maroon color. So another important characteristic of blood is it's slightly alkaline. So pH is about 7.35 to 7.45, and it's really tightly kept within that particular range. It also has a temperature that, believe it or not, is slightly higher than body temperature. It's about 2 degrees higher than body temperature, and this allows the blood to be able to act as a heat sink in the body. The other thing that I want to say just in general about blood is talk about the volume of blood in our bodies. So it usually varies between about 4 to 6 liters of blood, and typically males are kind of on the higher end of that, and females tend to be on the lower end of that, and that just has to do with body size. So males on average are larger than females. They tend to have a slightly higher blood volume, so maybe 5 to 6 liters of blood, whereas females tend to be more in the range of 4 to 5, just based on size. So the second thing that I wanted to get into is talking a little bit about the functions of blood, and we can kind of subdivide those into 3 different categories. So blood is a great transport medium in the body. If you think about it, it's this liquid pathway, right? This canal system that travels throughout your body. There's 60,000 miles of it, believe it or not, and it's very good at transporting all the things that need to go to different places in the body. It's very good at maintenance. So I talked a little bit already about how its temperature is higher than body temperature, and it's helping to regulate that and keep it consistent. It acts as a heat sink. You may have noticed when you go outside and it's cold that your skin gets really pale, right? And the reason for that is your blood, which is at a higher temperature than body temperature, is being sent into the core of the body to help keep the core of the body warm. If it's a hot day, you're outside, you're exercising, you may start to appear kind of flushed, kind of red, and the reason for that is your body's sending the blood, which again is at a higher temperature than body temperature, to the surface of the body, and you're seeing that redness from the excess blood there. But the reason is that it's using that to let off some body heat. Blood is also really good at maintaining fluid volume. So there's actually proteins that are contained within the blood that help to hold fluid in the blood, and that's really important for maintaining your blood pressure. If you lose blood volume, your blood pressure is going to drop, and we certainly don't want that to happen because it can cause all sorts of problems. So blood's really good at maintaining its own fluid volume and helping with the maintenance of the body in that way. There's one last kind of general function of blood, one other reason why we have it, and that is it's protective. So there are some cells in blood, they're called white blood cells. They are a part of the immune system, and they are really important for fighting against infection and helping us to be able to stay healthy. If you look at the PowerPoint slide, you'll notice what we're actually seeing is blood under a microscope in 3 dimension. And we've got some cells in there that are red that are kind of making the bulk of the blood. Those are the red blood cells, or what are known as erythrocytes. We've got some cells that are kind of this creamy yellowish color, right, that are not as abundant. Those are the white blood cells. And then you'll notice there's some much smaller kind of, they almost look like cell fragments, right? Just little things that are kind of a pinkish color that are there. And those are platelets. And those white blood cells are the cells that the blood has that help to protect against infection, help to keep the body healthy. The platelets are there because they're going to help with the other protective function of blood. They're going to help against blood loss. So if you get cut, we've all had cuts, right? You bleed. If you have a severe cut and you lose a lot of blood volume, that's going to drop your blood pressure really rapidly. And so platelets are there to kind of help with that if you do get an injury where you're bleeding, to help clot the blood so that it can protect against the loss of the blood and help to keep that blood pressure consistent over time. So with our second video in the blood section, we're going to get into exactly that, talking about platelets in more detail, talking about how the blood actually clots itself to help to protect against its own loss. So the last slide that I want to get into, kind of last topic that I want to get into with this particular lecture, is just talking more about the components of blood. So its consistency, what actually makes it up. And we've kind of started to talk about this a little bit already. With the last slide, I showed you red blood cells, right, or erythrocytes, white blood cells, which are also known as leukocytes, and then also the platelets, or the thrombocytes. So you can see in this slide here, this is a slightly different view from what we saw on the last slide, but this is blood. This is under just a compound microscope, so we're not getting a three-dimensional view, we're getting a two-dimensional view in this case. But you can see these different components that we've talked about. So the majority of this slide is made up of these kind of dusky red, circular red blood cells, or erythrocytes. You can see those there. We've got a couple of white blood cells. Previously, when you saw them on the last slide, they were this creamy white color, and that's where their name's coming from. Here they look purple, and the reason for that is just the dye that has been added to the slide to make them visible. And then you may also notice that we've got kind of these like little, they just look like shreds, really. These little teeny tiny little purple things kind of scattered throughout there. They're not extremely common. Those are the platelets, and those are the cells, or the cell fragments is what they actually are, that are going to help with the blood clotting process. So these cellular components, the red blood cells, the white blood cells, the platelets, collectively they make up what's known as the formed elements of blood. So we've talked a little bit about the formed elements, those cellular components, and when you look at blood as a whole, there's the solid component to it, that's the formed elements, those cellular components, but there's also a liquid component to it as well. The liquid component's known as plasma. Typically, plasma makes up about 55% of the blood by volume, and the formed elements, so those cellular components, the red blood cells, the white blood cells, the platelets, they make up on average about 45% of the blood by volume. Now there's some variation, those are just averages. What we see is that males tend to have a higher solid component to their blood, so they tend to have more red blood cells than females do. What we also see is that really well-trained athletes tend to have a higher solid component to their blood for reasons that you'll get into in the activity that you're going to do with this particular folder. But again, blood, if we look at its consistency, is about 55% plasma, about 55% liquid, and about 45% these cellular components, which collectively are known as the formed elements. I want to talk just a little bit more about the plasma. So it is a liquid. It is kind of a straw-colored fluid, so it's got a little bit of a yellowish tinge to it. It's this particular component of blood that's carrying the metabolic waste products that we talked about, that's carrying some of the respiratory gases that have to be transported through the body. It's where you're going to find the nutrients dissolved. It's where you're going to find the hormones. It's where you're going to find the procoagulants, or what are also known as clotting factors, which are going to become very important in our next video on this particular topic. So those things are all kind of dissolved, floating around within that liquid component of blood, the plasma. If we go back to the formed elements just a little bit, I want to talk about their functions, because understanding what they do specifically in the body is really going to help you with the activity that you work on for this particular unit. So first of all, the red blood cells are what are also known as erythrocytes. So eryth means red, cyte is cell, so erythrocyte like literally translates into red cell. Their job is to transport oxygen through the body. They are basically just sacs of a protein, which is known as hemoglobin, and hemoglobin's job is to bind oxygen. So basically these are oxygen binding cells. They pick up oxygen from the lungs and then they travel through, right, that canal system, that highway, if you will, 60,000 miles of blood vessels in the body to transport that oxygen to all the cells and all the tissues of the body that need it to go through cellular respiration. So that's their role. White blood cells we've talked about a little bit already. So those are our leukocytes. Leuc means white, cyte again is cell. So leukocyte literally means white cell, and they play a role in immunity. So they're present when there's infection. You're gonna really see their numbers increasing in the body when there's infection, when you're sick, because these are immune system cells that are, in the most literal sense there is, going after microorganisms and working to destroy them to keep your body healthy. And then the platelets are also known as thrombocytes. So thromb means clot, cyte is cell, so quite literally this translates to clotting cell. I've showed you these platelets or these thrombocytes on a couple of slides now. You'll notice that they're quite a bit smaller than the red blood cells. They're quite a bit smaller than the white blood cells. And the reason for that is they are cell fragments. They are literally a cell that grew and grew and grew and became very, very large and then split into like 10,000 different pieces and was released into the bloodstream to play a role in clotting. If you look at this part of the slide up here, what this is representing is the separation of blood into the different components that we've talked about. So we've got a person, they've had some blood removed, it's been put into a test tube. Here that test tube's been put in a centrifuge, which is a machine that just spins it very, very rapidly. And when you spin blood very, very rapidly, what happens is it's gonna separate out, and it's gonna separate out into its different components, which we just talked about, based on their density. So if you look at this test tube where we now have the blood separated, we've got the plasma up here at the top. Again, that's that liquid component of blood that has a lot of the things just kind of dissolved in it, floating around, right? The hormones, the clotting factors, those kinds of things. And again, you're seeing that that's about 55% of the blood by volume. If you look down here, so at the bottom, that's where our solids settled because they are the most dense. So we've got our red blood cells or our erythrocytes, and they're what actually makes the blood as a whole red. They are our heaviest component. They settle out to the bottom. You'll notice, if you can see this slide, that they make up about 45% of the blood by volume. And then we've got this little region in here that's known as the buffy coat, okay, that actually comes out as kind of the small little white layer in the middle. The buffy coat is the leukocytes, so those are our white blood cells, and also the thrombocytes, or our platelets, our clotting cells. And you can see that by volume, they make up less than 1% of the blood. So they're not something that's really common in the blood, but they are there and they do settle out into this middle layer when you centrifuge the blood and separate it out by density. So now that we've talked about the components of blood and we've looked at the erythrocytes, the leukocytes, the platelets, we've talked a little bit about the plasma, there's one last thing that you definitely want to be familiar with from this particular video, and that's a term which is known as hematocrit. So hematocrit is the percentage of blood composed of red blood cells. And so again, that's going to be about 45% of the blood by volume. As you were kind of researching things, sometimes in textbooks, sometimes online, there's a different definition of hematocrit that's given. And that definition says that hematocrit is the percentage of blood composed of all the formed elements. So the red blood cells plus the white blood cells plus the platelets. That's kind of the physiological definition, kind of the theoretical definition that you'll see used in academia, that you'll see used in textbooks. For the sake of this class, we're going to go with hematocrit is the percentage of blood that's composed of red blood cells, because this is the definition that you're going to see clinically. So if you have a whole blood count done, blood work done, when you get hematocrit, it's going to be giving you the percentage of red blood cells in the blood, which is a hugely important number because that tells you how many cells that you have available to transport oxygen throughout the body. So that in a nutshell is blood, and I'll see you on the next video where we continue talking about blood.